All right, scholars, let's pick up where we left off, building on this idea of a margin of error. So we are learning to comprehend that random samples produce different estimates for population characteristics, so I can describe the importance of margin of error when reporting an estimate for a population characteristic based on a sample statistic. That's a mouthful. I'll know I've got it when I can estimate the margin of error using the mean and standard deviation. Coins are usually stamped with the year and location of the mint they were made. D represents the mint in Denver, Colorado, and a blank or P represents the mint in Philadelphia. Diego has a jar containing 36 coins. Select a coin by using the applet. The applet is located here on this hyperlink. It'll bring you to a new tab where you can visibly see a random number generator. So in doing so, generate a pair two numbers, one for the row in the table and a second number for the column. That information is included in the PDF that I've attached to this Google Classroom assignment. If you land on a 3 and a 5, that would mean choosing the coin in the third row and fifth column, which is the coin marked 2000P. And we would type that in here accordingly. You might need to write it out on paper so you can view the entire table. Okay. At the conclusion, you'll calculate the sample mean year. So remember, when we're calculating the mean, the average, we would be adding the years from the 5 coins and dividing by 5 our total. And then I would like for you to calculate the proportion of the 5 coins that were minted in Denver. And we'll have a class discussion about those two values. But using that information, I would like for you to describe in words what information does the sample mean tell you, and what information does the sample proportion tell you. Next up, a political campaign sends volunteers out into various parts of the state to get a sense of how well their candidate will do in an upcoming election. 30 volunteers each get a random sample of 10 people in the state and find the proportion of people who are expected to vote for their candidate. The sample proportions are summarized in the histogram. Remember, when we are stating proportions here, we are technically stating the expected probability of that particular event. The average of these sample proportions is 0.55 and the standard deviation is 0.15. At this point, when we have information like that, we need to tap into this idea of a normal distribution and break down our data accordingly over the 68, 95, 99% ranges. As evident here, recall that for normally distributed data, about 95% of the data is within 2 standard deviations. What percentage of sample proportions are within 2 standard deviations of the mean for these data? Does this match what we expect from approximately normally distributed data? So looking at this table, or I should say this histogram, based on this information, what percentage of the data lies within 2 standard deviations? Does it equate to the expectation that 95% of the data should lie within 2 standard deviations of the mean? You can determine that because on the left-hand side we have our frequency, and we can determine how tall each bar is. I'll spare you reading this entire phrase, but the margin of error is the maximum expected difference between the estimate of the population characteristic and the actual population characteristic. With that being said, I would like for you to generate, because we are still exploring here, what margin of error should be given along with the estimate of 0.55 for the population proportion. Explain or show your reasoning. You might be sitting here and saying, margin of error. I'm still not really sure why we even need that. And it boils down to trusting random samples. Since we're deliberately using chance, the result obey the laws of probability that govern chance behavior. These laws allow us to say how likely it is that sample results are close to the truth about population. The second reason to use random sampling is that the laws of probability allow trustworthy inference about the population. Larger random samples give better information about the population than smaller samples. This is why we include our margin of error because, once again, we are making inferences which are based around or ground in inductive reasoning, which, once again, is from Unit 1. If you forgot what inductive reasoning was, inductive reasoning is using a specific set of events or data to draw a conclusion upon. The margin of error we constructed here was constructed at 95% confidence level. Since 95% of the time our sample proportion is within 2 standard deviations of the true proportion for the population, by using a margin of error of 2 standard deviations, we will capture the true proportion in our interval 95% of the time. Once again, complete speculation. What do you think would happen to the margin of error if we were okay with only capturing the true proportion 90% of the time? Would it increase or decrease? What would happen to the margin of error if needed to capture the true proportion 99% of the time? And why might someone choose a different confidence level? It is completely acceptable if you are sitting here at the end of this video saying, what just happened? Okay. At the very least, you should be able to make your way through slide 4. Slide 5 and slide 6 are very theoretical and conceptual. I strongly encourage you to read through the lesson 9 summary, and we will have a whole class discussion, fingers crossed, tomorrow during our class debrief.